question here is a wide question on Graham's law of diffusion. And the question is, if 100 centimeter cube of hydrogen diffused through a port in 1 second, how long will it take the same, mark this word, the same volume of oxygen to diffuse through the same port under the same condition? What are the two gases we have here? Hydrogen and what? Oxygen. So you have rate of hydrogen over rate of oxygen is equal to a very big square root. What is down here will now be up. Molar mass of oxygen that was down here over molar mass of what?
H2.
H2. Are we together? So the next one now. Hey, what is, we're asked to find how long. Is that not? How long means what? What does how long mean?
Means the period I take.
Time, Abi? The question, where is the how long here? How long will it take the same volume of oxygen? We don't know the time for oxygen to what? Diffuse. So we need to convert this R to time formula. We convert it to what? Time formula. We cannot see there a sheet of where you can see. Time formula. What is time formula for rate? Rate equals to volume over time. So rate of hydrogen, or can we just say, instead of rate of hydrogen here, hey, what do we put? We put volume of hydrogen over what? Over time for hydrogen. Everything now is representing the rate for hydrogen. Are we there now?
Yes.
Then this line like this, we now put it here, divided by rate, that's a volume of oxygen over time for oxygen is equal to square root of, what is the molar mass of oxygen? You are given here O equals to what? 16. And you have how many O here? 2. It now becomes 16 times 2. Are we there? Over molar mass of hydrogen. H is equal to 1. And we have how many H here? 2. It will now become what? 1 times 2. Now come back here. You can rewrite this thing as well. VH2. What is the volume of oxygen here? Volume of hydrogen is what? 100. What is the time to diffuse? 1 second. Diffuse in 1 second, Abi. Now this line can change it to what? Divided by this line. Change it to divided by. What is the volume of oxygen? They say, how long will it take the same volume of oxygen? If I get to talking there. The same volume of oxygen means that the volume of oxygen is also 100 centimeter cube as well. Hydrogen. So we have what? Divided by 100 over, what are we looking for? The time for hydrogen is not known. They say, how long will it take the same volume of what? Oxygen? So we don't know that. Time for oxygen is unknown. Then we come back here. We put our square root. 16 times 2 is what? 32.
32
over 1 times 2 is what? 2. Now, we come back here. Now, we rewrite this one as 100 over 1. Then we change this division sign to what? Times. This one comes up TO2 over what? 100. Then equals to square root of 2 here 1, 2 here what? 16. You have 16 over 1. Now this 100 cancels this 100. Are we together?
Yes.
Then we are now left with what? Time for oxygen equals to square root of what? 16 over 1. Now it's time to remove the square root. We take the square of both sides, Abi.
Yes.
We have TO2 square is equal to everything here, square root of 16 over 1 square. This will cancel this. So we now have what? TO2 square is equal to what? 16 over 1. Which is empty as what? 16, Abi. TO2 square equals to what? 16. What do we do to cancel this square?
Square both sides.
We take square root of both sides. Square root of TO2 square equals to square root of what? 16. This will cancel this. So TO2 square is equal to what square root of that? 4 seconds. Are we together? Yes. Then method 2. Now, who can remember the time formula? The time formula will not be what? Time for what? Okay, we want hydrogen to be up first, Abi. Time for hydrogen over time for what? Oxygen is equal to square root of what is up will be up here.
Yes.
Molar mass of hydrogen over molar mass of what? Oxygen. When you are using time, whatever thing that is up will be up, whatever thing that is down will be down. But when you are using molar rate formula, whatever thing that is up will be down, whatever thing that is down will be up. Are we together here?
Yes.
So the time for hydrogen has been given to be 1, Abi. If 100 cm of hydrogen that passes through a pulse in what? 1 second. We don't know time for oxygen. That's what we are looking for. Is equal to square root of what's molar mass of hydrogen? Hydrogen is 1. H equals to 1. But we have 2 here. We now have what? 1 times 2 over molar mass of oxygen. O equals to 16. But we have 2 here. We have 16 times 2. So here now we have what? 1 over CO2 is equal to square root of 1 times 2 is what?
2 over 32.
16 times 2 is what? 32. 2 here 1, 2 here what? 16. 1 over CO2 equals to square root of 1 over 16. To remove the square root now, you have 1 square over TO2 square is equal to square root of 1 over 16 all squared. This one remove this one, Abi.
Yes.
1 square is what? 1 over TO2 square is equal to 1 over what? 16. Are we together now? Now, what are we looking for? Now, we can cross multiply to make this one the chosen of the formula. So, what do we do about that? Let me use this space. Now, or let me just come here and use here to continue. I have 1 over TO2 square is equal to 1 over 16. I cross multiply. This one multiplies this. 1 times TO2 square. I write this equality sign. Equals to this one times this one, 16. 1 times anything is that thing, Abi. O2 square. 1 times 16 is what? 16. What do we do to clear this square? Take square root of both sides. TO2 square equals to square root of what? 16. This one cancel this. TO2 equals to square root of this one is what? 4 seconds. Which following? Yes. Number 2, write an expression to show the mathematical relationship between the what? The rate of diffusion and vapor density. According to Graham's law of diffusion, it says that the rate of diffusion of a gas is inversely proportional to the square root of the word density. So we represent R. Don't let me fight you. What are we doing? We use R to represent rate is proportional. Inverse is 1 over square root of what? Density. So I remove this sign, I replace it with equality, and I introduce what? Constant K times 1 over square root of what? Density. So I have R, K times 1 is what? K over square root of D. Then you now say where R is what? Rate of what? Diffusion. And what? D is what? Density. You are true. Density of gas. So that is what they ask you to do. Number 3, P total is equal to P1 plus P2 plus dot Pn. Where P total is the pressure of a mixture of gases. The equation above is an expression of what? What law?
West law.
A Grant's law, B Gay-Lussac law, C Boyle's law, D Dalton's law. Answer is Dalton's law. Why? How did I know? Dalton's law states that if 2 or more than 2 gases which do not chemically react together are put together in the same, in the same container, it said that the total pressure of the gas mixture is equal to the what? To the sum of the partial pressure of the individual gas that are present inside the what? Container. For example, if all of us here are gases, now, and you know gases will not sit down gently the way you are sitting down. They'll be moving randomly, colliding with one another and with the wall of the container. So as they collide with the wall of the container, they mount a pressure on the container called gas pressure. But the pressure of each of us, pressure of this man is partial pressure. Pressure of this one is partial pressure because partial is the opposite of total. Abi? The total pressure is the pressure of all of us. Are we there now? So the pressure of each of us is that this work we receive is the if this person will give this person blow, give the wall blow, they are giving the wall partial pressure. This person will also give partial pressure. This person, all of us will be giving partial pressure. So the pressure that each of the gas components inside the same container we use to collide with the wall of the container is called a partial pressure. So if we are to now get the total pressure that the wall of the container will receive, we now need to add up all the partial pressure of every board, all the gases. Am I talking to you? So that is what is here now. P total is equal to P1, which is partial pressure of gas 1, plus P2, partial pressure of gas 2, plus Pn, partial pressure of gas n. N is number, uncountable. Are we together now? The example I gave to you in the class, I use alphabet. PA, PB, PC, still the same thing. So it is what? That is of partial pressure. What is the partial pressure of oxygen at STP in a gaseous mixture containing 100 cm³ oxygen and 900 cm³ nitrogen? The mathematical definition of partial pressure is what? Mole fraction times P total. You still remember? So partial pressure, we are looking for partial pressure of what? What are we looking for? Of what? What is the partial? That's PO2 now. PO2 is equal to mole fraction of what? O2, Abi, times what? P total. And PO2 now, what is the partial pressure of oxygen? Partial pressure of oxygen, you should know now. I mean, mole fraction is what? Is number of mole of oxygen over number of mole of both oxygen and what? And the nitrogen, the two gases. You know there are only two gases here. What are the two gases?
Oxygen and nitrogen.
Oxygen and what? Nitrogen. But they say find partial pressure of only oxygen. So the numerator here will carry what? Number of mole of what? Oxygen. Over what? Number of mole of what?
Nitrogen.
Of nitrogen and what?
Oxygen.
And oxygen itself. Times what? P total. So what are we going to do here? What is number of mole of oxygen? That's number of mole is volume over molar volume. What is the volume of oxygen given to us? 100, Abi. 100. What is molar volume? 22,400 cm³, Abi. Molar volume of gas in cm³. In dm³ is 22.4 dm³, Abi. Times 1,000, that is 2 to 400 cm³, Abi. Now, over the same thing we write here, we are going to repeat it here. 100 over what? 2 to 400. Are we there? Plus, what is the number of mole of nitrogen? That's what? I mean, 900 for nitrogen over 2 to 400. Abi? Everything. What is the P total? What is the P? They say at STP. Am I talking to you? What is the, what are the SI units of the oceans? Atmosphere. There are 3 types of pressure that are standard pressure. First one is what? 760 millimeter mercury. Second one is 1.01 times 10 to the power 5 Newton per meter square. Then the third one is what? 1 atmospheric pressure. Which one are we going to use? Atmospheric pressure, because all the oceans carry what? ATM. We now say times what? Times 1. Do you notice that 22,400 is common to all of them, Abi? We may do without it. In mathematics, we can factorize it and cancel everything common, Abi? We don't need it. Just pick up this. This one can still be sent as what? 100 over 100 plus what? 900, Abi? Everything times what? Times 1. So what do we have here? 100 over 1000 abi 100 plus this times 1. So 2 0 cancels here. We have 1 over 10, which is at 0. What? 0.1 ATM. That's option what? Option A. Is it B? When we're doing partial pressure, Dalton's law of partial pressure, I told you we made mention of the case when water is collected over gas. Do you still remember? The partial pressure of gas is collected over water. Are we there? I drew a diagram here, which I will still rub up. If the gas is collected, we usually draw the diagram like this. You still remember? This is the diagram. So this is water. This is water. The water will enter here. This is water. But this is gas. The gas collected. The same gas that is entering here is now bubbled through this water to come and stay here. Are we together now? So it is collected over this water to come and stay above this water. What is the partial pressure? How many gases are now here? You have this. The wall of the container here is enjoying 2 types of pressure. First, the pressure of the gas, which we call P gas. Second is called PVS. Pressure of saturated vapor pressure from the back. Saturated vapor pressure of water. Because as the gas is passing through this water, it will turn to vapor. Are we there now? And it will now come with a vapor pressure of that water. It will turn the water to vapor. And that vapor will not be another gas in this place. We now have 2 gases. The gas that is collected and the vapor pressure. Am I talking to you? So we now have P gas plus what? PSVP. Saturated vapor pressure. To form our what? Our total P total pressure. Are we there now? So total pressure, which is all the pressure that are here now, is this. Then how do we now get the P gas? We want to make P gas very fun. Now what do we do? P gas will now become to what? P total minus what? PSV. What do we mean? Anytime you see a question like this, a general gas equation, they say if 200 centimeter cube of carbon 4 oxide were collected over water. When you see this statement, when you see that statement, go to the last part of the question. Go and check. They must write this thing for you. Standard vapor pressure of water. At, they will give you the temperature. Which temperature?
18 degrees.
18, which is this? Collected over water at what? 18 degrees C. Are we there? So, the saturated vapor pressure that is coming here must also be at what? 18 degrees C. It must be given to you. So, it's what? 15. So, you will take away this 15 from the what? Volume given to you. Because that volume given to you now is what? Is P total. Are we there now? P total like this. Why this saturated pressure is what? Is PSVP. Are we there now? Always take away, this 15 millimeter mercury from the pressure from this 700. Give it to you. Are we together now? But if they just say, if 200 centimeter cube of carbon 4 oxide was collected at 18 degrees C and 700 millimeter mercury, they did not say over water. They will not subtract anything. And they will not even write anything down. Are we together? That means it's a general gas law question. Are we together now? So what are we going to do? Okay, let's write out our parameter. Any number that is carrying centimeter cube in front is a volume, Abi. But because we meet it first, we write it as V1. V1 is what? V1 is 200 cm cube. Now, what is V2? That's what they say we should find. Before that, let's go. Centimeter cube of carbon 4 oxide were collected over water at least a temperature T1. Because we meet it first. Are we going to use 18 like that? No. We will convert it to Kelvin by adding what? 273. What is our answer now? Add 18 to 273. 273 plus 18. 8, 9, 10, 11. 291 be 291. Now, and the P1 now. P1 is what? 700 minus what? 15. It will give us what? Press. 685 millimeter mercury. Then the next one is that they now say what? Determine the volume. We don't know. They are giving us one volume. They say we should find another volume. That second volume will not be what? V2 is on no. Of the dry gas at STP. What is STP? It means standard temperature and pressure. It means your T2 will be standard temperature. And standard temperature is what? 273 Kelvin. While your P2 will be standard pressure. The standard pressure that carries millimeter mercury is 760. So we now have what? T2 now is 273 Kelvin. While P2 is 760 mmHg. So using general gas equation now, using general gas equation now. Who can remind me? V1 over T1 equals to V2 over T2. What am I looking for? I'm looking for V2, Abi. Let me just cross multiply and make it here. Cross multiply now, you have what? T1, which is this one.
V2.
Then V2. Then P2 equals to now all this one here now. P1, then you need to multiply T2. This one. T2. What am I looking for? I'm looking for V2. You divide both by T1 and P2 surrounding it. Yes, madam. I'm coming, man. It's in the lab. I'm coming. I'm going to divide by what? T1, P2, Abi. I'm coming, man. You have V1, P1, T2 over what? T1, P2, Abi. So this one will cancel this. This one will cancel this. Our V2 now will be what? What is my V1?
V1, P2.
What is my V1 now? 200.
Yes.
Times what is my P1? 685. What is my T2? 273. Everything over. What is my T1 now? 291. What's my P2? 760. Oh, yeah, multiply all these three. I don't understand though. 200 times 685 times 273. 200. 3 zeros, Abi?
Yeah.
Over here, 291 times 700, 760.
Equals to 976795.
976795. Oh, yeah, divide. Final answer now.
Yes. The final answer is 97.
Oh, God. Follow me, do this thing. I'm already writing now. You want me to, okay, I should leave this one and go and write final answer. What about calculation is that one? 2, 2, 1 what? 1, 1, 6, 0. Have you not divided now? 1, 2. Press a bell. Please let another person press. 169.113 over. Okay, that's all, Abi. That's a centimeter cube. Yes. A cylinder contains 2 moles of O2, 3 moles of CO2, and 5 moles of N2 at a particular temperature. If the pressure in the cylinder is 210, pressure in the cylinder, that means the total pressure. Are we together now? They now say calculate the partial pressure of oxygen. P oxygen. Partial pressure of oxygen is equal to mole fraction of oxygen times what? P total. Are we together? And what is the mole fraction? P P oxygen. What show? Hey. P oxygen will not, among fraction of oxygen will not be what? Number of mole of what? Oxygen over how many gases that are there? Number of mole of the same oxygen plus number of mole of carbon dioxide plus number of mole of what? Nitrogen. Everything here times what? P total. Why am I putting oxygen up? Because we are looking for the partial pressure of the oxygen. So this will now give us, what is the number of mole of oxygen here? That's 2, Abi. I put 2 here. Over, what about the same oxygen? 2. What is the number of mole of CO2? 3. What is the number of mole of nitrogen? 5. Everything here, what is our P total? Times what? 210. Abi? So what do we have? 2 over, add up this one. That's 10, Abi. Times 2, 10. Hey. So 0 cancel 0. So we have what? 2 times 21 is what? 42. What is our answer? 42 Newton per meter square. Why am I using Newton per meter square? Because the partial pressure they give us here, the unit is what? Newton per meter square. They say calculate the vapor density. What is the formula for vapor density? Molar mass over 2. You still remember? Because vapor density is what? Is the number of times the what? The volume of a fixed mass of gas is as heavy as equal volume of what? Of the mass of hydrogen. And the mass of hydrogen is 2. So vapor pressure equals to molar mass over what? 2. So they already give us, they say calculate the vapor density of a triatomic gas H if its relative atomic mass. Hey, this is relative atomic mass, so not relative molecular mass. Hello? Hey, this is relative atomic mass, just like the open bracket. To open bracket and say X equals to 16. And they say the gas is what? Triatomic. X3. So what do we do to get the molar mass? 16 times what?
3.
16 times 3 over what? 2. So 2 here, 1. 2 here, 8. 8 times 3 is what? 24. That's all.